SQL versus NoSQL. Why did Supabase go the traditional route when Firebase went NoSQL? Let's find out. When Supabase launched, many developers expected it to follow the trend set by Firebase and opt for a NoSQL database, since Supabase was considering itself as an open source Firebase alternative. Instead, Supabase chose PostgreSQL, a relational database system that has been around since the 1980s. Was this a step backward? Not at all. Let's explore why Supabase made this decision and what it means for us developers. First, what's Supabase? Supabase is a serverless backend service that uses PostgreSQL to help developers build scalable applications. It provides services such as authentication, real-time subscriptions, and an easy-to-use API, making it a powerful alternative to Firebase but with the flexibility and robustness of SQL. As you're aware, I have been working on a tutorial on Supabase and Flutter and shared the first part at the end of last year. We'll talk about that later on. Before diving in, let's take a moment to understand the broader debate. NoSQL gained popularity due to its flexibility and scalability, especially for real-time applications. However, SQL has remained the standard for data consistency and integrity. Firebase, or NoSQL, is known for its speed, while PostgreSQL that uses SQL is known for its robustness. So why did Supabase bet on the latter? First, PostgreSQL is an ACID-compliant database. What that means is it ensures data consistency and reliability. NoSQL databases such as Firebase's Firestore offer flexibility but often compromise on data consistency, which can lead to unexpected behavior in complex applications. Let's take a simple example: banking systems versus social media feeds. If you're building a banking app, even a slight inconsistency in transaction records can cause major issues. PostgreSQL ensures every transaction is recorded accurately. PostgreSQL or MySQL, in this case, it's PostgreSQL. However, for a social media feed, slight inconsistencies, e.g., a delayed comment appearing, or even creating dynamic comment schemas or design of the comment, they aren't that critical, and that's where NoSQL database shines in unstructured data. With PostgreSQL, developers can perform complex queries using SQL, a language that has been refined for decades. NoSQL databases often rely on workarounds to achieve similar functionality, making them less efficient for data-heavy applications. Let's take an example. Imagine you're running an e-commerce store with millions of products. PostgreSQL allows advanced filtering, like you can show products under $50 with at least 4-star ratings. Another will be listing items in stock sorted by popularity. You see, NoSQL would require extra data structuring and multiple queries to achieve the same result efficiently. While NoSQL databases are often praised for their scalability, PostgreSQL has evolved to handle massive workloads efficiently with features like partitioning, indexing, and parallel query execution. It can scale horizontally and vertically while maintaining a structured schema. Also, one common misconception is that SQL databases lack flexibility, which is not the case. PostgreSQL's JSON-B support allows developers to store and query semi-structured data, giving them the best of both worlds: structured relational data with NoSQL-like flexibility. So there is a data type called JSON-B that you can use to handle those semi-structured data that you may want to store. So one challenge with traditional SQL databases is the steep learning curve. It requires some learning time. Supabase has tackled this by providing an easy-to-use API. It's so easy, guys. Developers, you can interact with PostgreSQL database using RESTful or GraphQL. The moment you get into Supabase the Supabase dashboard and create a new project or use Supabase CLI, it automatically creates a database for your project. And all you have to do now is just design your database schema and then access your tables through an automatically created API endpoints. Great. Another thing will be it offers real-time capabilities which mimics the functionality of Firebase, and this is just a matter of checking or unchecking a specific um, feature in Supabase based on a table. And lastly, which is usually very important when it comes to security, is that it simplifies the authentication and permissions face or functionality with the help of role-based access control RBAC and row-level security RLS, which make managing users and permissions straightforward, where you get to create policies and be able to it automatically links those policies to the specific tables that you want those permissions to be executed. So imagine creating a chat app with Supabase thanks to its real-time capabilities. So you can send a message and see it instantly appear on another user's device. Use PostgreSQL's JSONB to store structured message metadata, for example, timestamps, reactions, and you can also secure messages with row-level security rules so that you prevent unauthorized access. In essence, Supabase takes the power of PostgreSQL and wraps it in a developer-friendly interface, making it as easy to use as Firebase without sacrificing flexibility. And that's a winner on Supabase. As I have interacted with Supabase, I've seen how easy it is to interact with it, to work with it, to create a project and implement or inject the specific services that I would want for my project. And guys, it's a developer friendly for sure. While PostgreSQL is a powerful choice, there are cases where NoSQL shines. We're not trying to degrade NoSQL, right? So if your data structure changes frequently or your project depends on unstructured data, a NoSQL database can save time quickly. So you have highly dynamic schemas involved. NoSQL is often better suited for logging and event-driven applications because it can handle massive unstructured data quickly. Remember speed, that's the power of NoSQL. And for real-time chat applications or caching system, NoSQL databases may offer faster performance. For example, Firebase's Firestore. So for example, for a fast-paced multiplayer game where thousands of players update scores every second, a NoSQL database like Firestore could process reads and writes with lower latency involved. So Superbase's choice of PostgreSQL over NoSQL, as you can see, wasn't just about sticking to tradition or making itself different from Firebase by just one factor. It was about building a platform that balances power, flexibility, and developer experience. For projects that require structured data, strong integrity, and advanced querying, PostgreSQL is the clear winner. And thanks to Supabase, it's now easier than ever to use it. I feel like the people who created Supabase, they created by Supabase was created by developers for developers because the experience is very beautiful. So what do you think though? Will you choose PostgreSQL or NoSQL for your next project? Let me know in the comments. And if you enjoyed this breakdown, don't forget to like, subscribe, and share. As you're aware, I have been working on a tutorial on Supabase and Flutter and shared the first part end of last year, which is long overdue. Sorry about that. Thanks to the incredible feedback from many of you and the generous support of those who want to help me continue creating, I'm excited to announce an upcoming membership right here. This will allow me to provide full and finished in-depth tutorials from the start every month based on the topics you want us to learn. Your support means the world to me, and I can't wait to build this with you.